Welcome to heat transfer video lecture series. In this topic, we will discuss about the radiation heat exchange between gray surfaces. So, is the radiation heat exchange in between the gray surfaces is an important topic in heat transfer. So, the gray surfaces refer to materials that have emissivity independent of wavelength but less than 1. In the meaning, they do not emit radiation perfectly as a black body. Here's breakdown of the key concepts and gray surface definition. The gray surface has an emissivity that is less than 1 but constant overall wavelength. For such surfaces, radiation properties are simplified compared to real materials where emissivity can vary with wavelength, and it focuses on the Stephen Boltzmann laws concept also. The rate of heat exchange due to the radiation between two surfaces depends on the Stephen-Boltzmann law is V factor, and the V factor accounts for the geometry between the two surfaces involved in radiation. It represents the fraction of radiation leaving surfaces and that directly reaches surfaces, and it depends on the shapes and the relative orientations of the surfaces. And radiative heat exchange between two gray surfaces or the net heat transfer rate between two gray surfaces can be calculated using the formula of Q is equal to del T by R, and net radiation heat exchange. The net radiation exchange between two surfaces also depends on their surroundings and any barriers to radiative heat flows, such as insulation. In practical applications, gray surface models are often used because they simplify the mathematics while providing reasonable approximations for many types of materials. So this is the concept of the radiation heat exchange between the heat surfaces or is A1, A2 and radiation is body is A2 and T2. So in these radiative heat exchanges between the surfaces can be concluded using the formula, and net radiation exchange between surface also depends on their surroundings and any barriers to relative heat flow. So these are the important keys parameter sections will be adapted in radiation heat exchange between the gray surfaces and neutralized part of the value. So in this, the emit radiation is a black body is concept is due to the breakdown in the during the session of a surface definition, and a gray surface as an emissivity and that is less than 1 but constant overall wavelengths. In surfaces, the radiation properties are simplified compared to the real materials where emissivity can vary with wavelength, and using the Wind displacement law. And this Wind displacement law is how to adapt or how to interact with the area of the Stephen-Boltzmann law. Once again, I will remember about the revised about the Stephen Boltzmann law is the rate of heat exchange due to the radiation between two surfaces depends on the Stephen Boltzmann law. And B factor and accounts for the geometry between the two surfaces involved in radiation. It represents the fraction of radiation leaving a surface in the directly letter of the surface G. It depends on the shapes and the relative orientations of the surfaces and radiative heat exchange between the two gray surfaces. So the heat transfer rate between the two gray surfaces can be calculated using the formula and net radiation exchange between the surface, and also depend on their surroundings and varies to radiative heat flow such as insulation. So this is the practical and concept of the radiation heat exchange in heat flow of radiation in both the area and gray surfaces. I will conclude this session about on radiation heat exchange in the laws of definition, laws, view factor, radiative heat exchange of gray surface, radiation exchange, and images of the shape factor and the radiation exchanges of the heat exchange between the heat gray surface in a radiation heat transfer phenomena. I hope that this session will be all of you know about the about the pre-surface heat transfer radiation in the particular wavelength and phenomena. Thank you.